This video is on Unit 2, Chapter 6, Quadratics Extras, Lesson number 2 on Quadratics Projectile Motion. Before I get started on the examples, I want to go over some basics about projectile motion. So with projectile motion, we are going to be only talking about the first quadrant in a coordinate plane. There will be times when it may go into the fourth quadrant, but I'll talk more about that later. The other thing that you need to know is that the x-axis is always going to be the time, which is also referred to as the independent variable. The y-axis is the height, which is the dependent variable. So in this figure that I've got drawn out here, this is just quadrant 1, and you can see the x-axis, which in these types of word problems is going to be like ground level. It might be water. There are some of these word problems that deal with jumping into water, and so that's when we might see some of our answers go into the fourth quadrant. But for the most part, the x-axis would be ground level, and again, it's the time. Your height is the y-axis. And then all of these are going to be quadratics. A projectile, which is something that is thrown, the path is always a parabola. It creates a parabola. And in a parabola, the points at which the parabola hits the x-axis, again, are called those zeros or roots. And basically, it's where the object starts on the ground or comes back down to the ground. The other piece that you need to be familiar with is the topmost point in the parabola, which is the vertex. Now, that's what we call the maximum point. It is an ordered pair, x, y. And again, in projectile motion, remember that the x is the time and the y is the height. So those are just some basics that you need to be familiar with as we go through these word problems. So let's go back to example number 1. A soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation h of t is equal to negative 16t squared plus 90t gives the height h of the ball after t seconds. So basically the scenario that we have going on here is a quadrant 1 kicking from the ground level up, and then it's going to come back down and hit the ground. The question A says, how many seconds will it take for the ball to reach its maximum height? So it's asking about that maximum point. Sorry, I'm messed up the zoom there. So the maximum point would be this point right here. And the calculator can spit that information out for us. To do this, what we need to do is we need to go to y equals. So we're going to go to the calculator, and we're going to take this equation and we're going to put it into y equal. Now the h of t is the same thing as a y, and the t, we can't use a t in the graphing calculator. We're going to have to use an x. So let's go to the graphing calculator. We're going to go to y equal. We're going to put in the negative 16, use the x squared, plus 90x. And then we're going to graph this. And I'm going to hit zoom 6 because I'm not sure what I've done on the calculator recently. There's another neat feature that the calculator will do. If you hit zoom again and arrow down, I'm going to arrow down to the next screen. You'll see here at the bottom of my screen where it says quadrant 1. So it's highlighted on that one. So I'm going to hit enter. And what it does is it focuses everything in quadrant 1 only. So this is the x-axis of quadrant 1. Here's the y-axis in quadrant 1. I can't quite see all of my parabola, so I'm going to zoom out. Zoom 3, enter is zooming out. So here again, we're only focusing on quadrant 1. This point is where the soccer ball started. It was kicked up into the air, and then it reaches its maximum point somewhere up in this area, and then it comes back down to the ground here. question A is asking about the maximum height. To do that, we're going to hit second trace. You'll notice that the number 4 here is maximum. Now, this is the same place that we went to do intersection, but we're going to do maximum. So I'm going to select number 4. This next part, you really need to kind of focus on and listen to what I'm saying, because it's kind of confusing in a video. At the bottom, it says left bound. What that means is you have got to tell the calculator a region to look. And it's asking you, I need you to put your cursor on the left side of whatever it is that you're looking for. So I'm looking for some point way up here that's off the graph. And I need my cursor to be on the left side. So I'm going to hit the left arrow key. Now you should have just seen my cursor. I'm going to keep going, hitting left, hitting left, hitting left, hitting left. Okay, so there's my cursor. Here's my cursor. It is on the left side of the parabola. Therefore, it is on the left side of that maximum point. I'm going to hit enter. And what you might have seen is this little arrow that popped up. So that's the left boundary. It's going to go from this point over, and look, now it's asking for a right boundary line. So now we've got to be on the right side of that maximum point that's up here somewhere. So I'm going to arrow to the right until I see the cursor come up on the right side. Okay, it's on the right side now. And when I hit enter here, you can then see this arrow again. Now, the left arrow is pointing to the right. The right arrow is pointing to the left. And basically what you've told the calculator is, I need you to look between these two arrows for that maximum top point. Right now it's on a guess, which we don't care about. You need to hit enter one more time, and it tells you that the maximum is 2.81. We're going to round this to 2.812. 2.812. And 126.56, we're going to round that to a 3. So let me go back to my notes here. So this top point we said was 2.812 and 126.563. Okay, so what does that mean? That means this is my seconds and this is my height. This is my time and this is my height. Okay, so question A says, how many seconds will it take for the ball to reach its maximum height? Well, that's going to be that 2.812 seconds. And then part B says, what is the maximum height of the ball? That's going to be the 126.563. And I think we're going to be in feet. Yes, feet. We're not going to worry about questions part C on question number 1. All right, let's look at question number 2. An apple is launched directly upward at 64 feet per second from a platform 80 feet high. The equation for this apple's height, h, at time t seconds after launch is h of t is equal to negative 16t squared plus 64t plus 80. What is the height of the apple after 3 seconds? Now this one's a little different. I'm going to come over here in this margin where I've got space to show you. This one says that the apple is being launched from a platform that's 80 feet high. So instead of the parabola starting here, the parabola is actually going to start above that point on the y-axis. So there's a platform here, imagine, and we're going to launch this apple up, and then it's going to come back down and eventually hit the ground. Now, the question that we're being asked, an apple is launched directly upward at 64 feet per second from a platform 80 feet high. The equation of the apple, blah, blah, blah. What is the height of the apple after 3 seconds? So what it's asking, let's say that this is 3 seconds. it's asking, what is the height here? Well, here's the trick. If you can remember that the time is the x, that means we're going to look for where x is equal to 3. Now, there's two different ways you can do this. You can just simply substitute 3 in for the time. So in other words, you're going to take negative 16 times 3 squared plus 64 times 3 plus 80. And that's going to give you the answer. Or the other way to do that is to go to y equal. And again, I can put in my equation negative 16x squared plus 64x plus 80. And I can just go to the table of ordered pairs where x is equal to 3 and find my answer is 128. So answer to question number 2 is 128 feet. So again, I showed you two different ways of doing that. You can plug it in, or you can take your equation, put it into y equal, and look at your table of ordered pairs. Number 3, a toy rocket is launched vertically upward from a 12-foot platform. So number 3 is very similar to number 2 in that the rocket or the toy rocket is starting on a platform. It's being launched up, and then it's going to come back down to the ground. With an initial velocity of 128 feet per second, its height h at time t seconds after launch is given by the equation h of t is equal to negative 16t squared plus 128t plus 12. How long will it take the rocket to reach the ground? So this one's asking for this ordered pair right here. How long before it reaches the ground? What I'm going to do is I'm going to again put the equation into y equals. So go to y equal, clear. The equation again was negative 16x squared plus 128x plus 12. And then I'm going to hit graph. So what I'm looking for is this point right here. And if we hit trace, the cursor is only going to stop at certain points. So it's going to stop here, which is not where I need it to stop. If we hit a left arrow again, it's gone. So trace is not perfect. The table is not going to work either because I need to know where is y equal to 0. So the table is not going to help me. So let's look again at the graph. This point right here is a 0 of the function because it's where it hits the x-axis. So second trace, number 2 is a 0. Now, if you look at the bottom, and once again, it says left bound. Now, this one's really hard to get on the first time through, so watch carefully. Here's the point that I need. The calculator is asking me to put my cursor on the left side of this point right here. So I'm going to try to find my cursor. Okay, here's my cursor. So right now, my cursor is technically on the right side of that point. And it's really difficult to see that. I'm not sure that you're catching it, but it's on right now, it's on the right side of that point. It's below and to the right. So if I hit the left arrow key, it's gone up and over to the left. I'm going to zoom out just a little bit. Zoom 3, enter. I'm going to zoom out one more time, which is kind of a bad plan, but this is the point I'm looking for here. The cursor is above it. So that means it's on the left side of that point that I'm looking for. I'm going to hit enter. No, I'm not. I'm going to hit zoom 6. Looking for this point. Second trace, number 2. I'm looking for this 0. I'm going to hit I'm going to hit the right arrow. I need to hit the right arrow. I need to get close to that point. Bear with me. I'm working on it. Okay. So here's my cursor. Y'all, again, it's so hard to see, but the point where I've got that circle is the point I'm looking for. And I don't know if you can tell or not, but the cursor is on the left side of that point. It's on the left. So because it says left, I'm going to hit enter. And then I need to hit the right arrow key because I need to be on the right side. So I hit the right arrow key. I'm going to enter. I don't know if you can tell or not, but the point that I'm looking for is between the two dotted lines. So that's where the calculator is going to look. I'm going to hit enter one more time. And it says that the 0 is at 8.09. We're going to say 3, 8.093. So 8.093. How long? That's going to be in seconds. Number 4 is next. A penny is dropped off the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled by the equation h of t is equal to negative 16t squared plus 1,250, how long will it take the penny to strike a 6-foot tall person? This one is completely different from the others. So what you have on this one is a penny being dropped from a building. It's not going to be launched up. It doesn't go up and then down. It's just going to be dropped. And so it's half of that parabola. That point at which it's being dropped is the vertex. It's asking how long will it take for the penny to strike a person that's 6 feet tall. So we're not even looking for the 0. We're looking for, if there's a 6-foot tall person down here, how long is it going to take for that to hit that person? So a 6-foot tall person, that means that the y is equal to 6 because that's height, the distance above the ground level. With this one, I'm going to just simply substitute that in. Remember, h of t is y. So 6 equals negative 16 t squared plus 1,250. Now, the nice thing about this equation is if you think back to how we solve quadratics, there's no bx on this one. So we're going to use square roots. I'm going to subtract the 1,250 because when we solve by using square roots, remember you got to get the x squared, or in this case, the t squared by itself. So 6 minus the 1,250 gives me negative 1,244. Then we're going to divide by the negative 16. And we get 77.75. And then we're going to square root both sides just like we did before. Now, you'll notice that I haven't stressed too much about these decimals. And this is one of those lessons where it is okay to have decimal answers. We're going to call this 8.8, we'll say 8.82 seconds. That's how long it's going to take for the penny to hit the 6-foot tall person. All right, there's 2 more that I want to look at. Number 7, Eva is jumping on a trampoline. Her height h at time t can be modeled by the equation h of t is equal to negative 16t squared plus 20t plus 6. Would Eva reach a height of 14 feet? Y'all, this is asking about the maximum. So what we need to do is we need to put this into y equal and calculate that maximum and see if she's going to reach 14 feet. So going to my y equal, clear out the old, I'm going to put in the negative 16x squared plus 20x plus 6, and I'm going to hit graph. Now, I know I can't see the top of this, but I know it's right there. I'm going to hit second trace. I'm looking for the maximum point, so I'm going to hit number 4. Left bound again. Notice that my cursor is already on the left side. These are so much easier to see. The maximum point's up here, and it's so easy to see that the cursor is already to the left of that point. So let's just go ahead and enter now. And then we need to go to the right side of that maximum point. And again, it's easy to see I'm on the right side. Hit enter again, and then enter one more time. And it says that the maximum is at 0.62 and 12.25. Now, again, what this means is at 0.62 seconds, she is 12.25 feet in the air. That's as high as she's going to get, 12.25 seconds. So the question here was, will she reach a maximum height of 14 feet? The answer is no. Sorry. The answer is no, because her maximum height is only 12.25 feet. All right, last one is number 8. A driver is standing on a platform, a diver. A diver is standing on a platform 25 feet above the pool. He jumps from the platform at an initial velocity of 10 feet per second. Use the formula h of t is equal to negative 16t squared plus vt plus s, where h is the height above the water at time t seconds, v is the starting upward velocity, and s is the starting point to write an equation to model the dive. Okay, so v is the initial velocity, and the initial velocity is 10 feet per second. And then the s is if they start on a platform or above ground level, and that's going to be the 25. So h of t is equal to negative 16t squared plus 10t plus 25. So there's the equation. Part B says find the diver's height after 2 seconds. So again, 2 seconds, that's my time, that's my x. X equals 2. So I'm going to go to y equal, let me back up. Here again, x equals 2 or t equals 2. You could very easily just plug in the 2. Negative 16 times 2 squared plus 10 times 2 plus 25. And you would be done. So let me show you what that would look like. Negative 16 times 2 squared plus 10 times 2 plus 25 gives me negative 19. So negative 19 feet. What does that mean? The height after 2 seconds is negative 19 feet. What that means is he's 19 feet underwater. So basically what happened on this one is your x-axis is the water surface. This diver jumps off of a platform into the water, and after 2 seconds, they are 19 feet below the water. So I would say you can say negative 19 feet, you could say 19 feet below the water. Both of those answers are fine. I do want to also show you one thing very quickly. You could have on that one plugged in the negative 16x squared plus 10x plus 25 and gone to the table of order pairs where it's equal to 2 and gotten the same answer. All right, so those are your notes for this lesson on projectile motion, lesson number 2.